Hello, my name is Shanik Anju, and today I will be determining the velocity of the object just before it leaves this ramp and enters projectile motion. In order to do so, I can use three different methods. The first method is by utilizing this first phase, in which the object has a constant acceleration. The second method is by utilizing this phase, phase 2, in which the object has a constant velocity. The third method is by utilizing the last phase, in which the object enters its projectile motion. So after conducting this experiment, I have recorded my data and performed the necessary calculations. So for the part in which it has constant acceleration, I need to find the velocity of the object just before it ends the phase in which it has constant acceleration, because that will tell me the velocity of the object just before it leaves the ramp. So during the part in which it has constant acceleration, the acceleration itself is unknown. It displaces 1.21 meters in the x direction. The final velocity is what we need to find. The initial velocity is 0 meters per second because it starts at rest. And the time it takes for all of this to happen is 1.32 seconds. So I have a few kinematic equations for me to use. As you can see, the best fit for this situation is this equation here. So if you look at my calculations, I plug in the values for all of the variables and solve for the final velocity to obtain a result of 1.83 meters per second. So for part 2 of the experiment, the object has a constant velocity, which means that the initial velocity of the object is equal to the final velocity of the object. And we are given the following information. The acceleration is 0 meters per second squared, especially because this has a constant velocity. It displaces 1.22 meters in the x direction. The final velocity is again what we need to find. The initial velocity is not 100% surely known, and the time it takes for this to happen is 0.65 seconds. So the best kinematic equation for us to use at this point is simply the average velocity is equivalent to change in displacement over change in time. So as you can see in these calculations, I obtain a result that the average velocity is equal to 1.88 meters per second. So the final method for which I could have calculated the velocity of the object was using projectile motion. I utilized carbon paper in order to find the range of the object after it leaves the ramp. And what I found was that the range of the object, or the displacement in the x direction after leaving the ramp, was 0.82 meters. The average velocity is what we needed to find, and the time it took for this to occur is 0.45 seconds. Once again, I can use the kinematic equation. Average velocity is equal to displacement over change in time. As you can see, after performing the necessary calculations, I obtained the result that the average velocity is equal to 1.82 meters per second. So as you can see from my results, I obtained the result during phase 1, the final velocity was 1.83 meters per second. During phase 2, the velocity was 1.88 meters per second. And for phase 3, the velocity was 1.82 meters per second. So why aren't these results all the same? Well, there are a few sources of error that could have caused for this experiment to go wrong. Number 1, I assumed that friction was negligible in all 3 cases. And number 2, there is a random error in which the human reaction time delays the timing, so therefore we cannot get the most precise measurements of time. Those are the 2 ways in which this experiment could not have been completely accurate. For the ELA component of my project, I have decided to write a narrative essay describing my experience with this PBL experiment. I explained the numerous obstacles and setbacks I had to overcome in order to successfully complete my project. Furthermore, I explained how PBL experimentation, combined with the knowledge I gained from my physics teacher's lectures, helped enhance my knowledge of kinematics as a whole. Overall, this PBL project helped me learn a lot about physics, and it helped me comprehend many challenging kinematics concepts and ideas. For the social studies connection in my PBL project, I've decided to associate my experiment with the history of roads and their uses.
The reason I did this is because my experiment models the effect of varying tracks on the overall course and motion of an object. Similarly, the construction of roads throughout history played an important role in the transportation of people, cars, trains, and even airplanes. Civil engineers have the critical task of designing roads in a practical way, such that they are safe to walk or ride on and they minimize traffic conditions.